the next topic is related to mathematics. Okay, mathematics plays a fundamental role in programming like algorithm, statistic, and probability. So I would like to invite Mr. Cham Loon to explain more about mathematics in computing. Thank you.
Thank you, Dr. Nohayati. Okay, I'm Cham here. I'm going to share with you on the importance of maths to computing pathway. Let me share the slide first. I hope everybody can see the slide here, right? So I'm going to share you the idea of this importance of mathematics in computing pathway. So first of all, let's ask a question on why does the computing area require maths? Okay, so especially for those students, they wanted to pursue their pathway in computing, so they need to know about the maths. Okay, now we see the first thing we notice that in today's digital age, right? Okay, the field of computing, particularly computer science, is driving innovation and shaping the futures. Since the technology integrates further into all aspects of our life, the demand for computer scientists continues to grow, making it one of the critical and rapidly expanding sectors in the job markets. Right? So, for the student to succeed in studying computer science, a solid foundation in mathematics is vital. All right, mathematical reasoning equips computer scientists with the ability to identify coding errors and tackle those complex problems. All right. So, moreover, studying maths enhance problem-solving skills that are applicable to a wide array of real-world challenges. Right? So let's see on the computing areas that requires for maths, especially we explore the first area in computing is algorithm design. So mathematical logic is to ensure algorithms are efficient and reliable. For example, binary search use logarithmic time complexity, making the algorithm much faster than the linear search. All right. So we explore the another area for computing, data structures. So the efficient storage and retrievals of data are based on the mathematical principle. All right. So for example, the hashing function, which is from the number theory that allows the quick lookup in database, large database, right? So in cryptography areas, okay, complex encryption techniques rely on number theory as well, right? So for example, RSA encryptions use prime factorizations to secure the online transactions. While the popular area in computing, okay, before you talk about the AI, right? So you need to know about the machine learning, right? So linear algebra and calculus are used for building and training models. For example, gradient descent, which is from calculus, is applied to minimize error in machine learning models. Okay, now let's explore mathematical area in computing pathway. What are the mathematical areas? Huh? So the first one that we are going to see is the algebra in computing. So the algebra itself covers linear algebra, Boolean algebra, and abstract algebra. So itself, linear algebra is essential for computers, graphics, machine learnings, and computer visions. For example, representing image as matrices and applying transformation like rotation and scaling. All right. So then for the Boolean algebra, right, is used to form the foundation of logic gates and computer circuits. For example, the AND, OR, and NOR gates used in CPU to perform computations, right? And abstract algebra used in cryptography algorithm. For example, elliptics, curve cryptography use a group and fields from abstract algebra to secure communications. All right, so this is a few of this algebra, okay, and you apply to the computing area. And we look at the next one for mathematics area, calculus. Okay, so we will use a calculus for optimization problems. Okay, calculus help in optimizing function for better performance. For example, gradient descent is used in machine learning to optimize a model by minimizing error functions, right? Let's look at the discrete mathematics in computing, which covers set theory, graph theory, combinatories, and logics. Okay, so set theory is essential for database management system. For example, SQL queries use concept from set theory to retrieve and manipulate data. All right. So graph theory is mainly used for network design, search engine, and social media analysis. For example, Facebook friends suggestions algorithm use graph theory to identify mutual connection, right? So next, connection combinatories and logics, okay, which is very important for counting problem, optimization, and programming language. For example, scheduling problem and conditional statements, if and else, that introduced by Dr. Marcus just now. Okay, so one of the applications actually is you can actually insert these things inside the if else things. All right. So next areas, okay, for probability and statistics in computing, we do have application to machine learning. So let's look at the predictive modelings use probability and statistics to make decisions. For example, naive Bayes classifiers use probability to categorize email as spam or not, all right? And then data analysis, statistics help in making sense of big data and drawing conclusions. For example, statistical algorithms are used in recommender systems like Netflix or Amazon. Okay, in the popular areas, AI and decision makings, all right? So probability help in decision making processes in AIs. For example, okay, the popular mathematical tools, Markov chain, are used to model decision making in AI system. All right. So such as predicting the next move in a chess games. Okay, so this is one of the applications. So let's look at the number theory that just now I have briefly introduced, right? So number theory is mainly used for the cryptography, especially. So let's see the cryptography here. So this number theory is a call to encryption methods that protect data online. For example, the RSA encryption algorithm use the difficulties of factoring large prime number to ensure security. All right. And we do have the hashing functions, okay, used to store and retrieve data efficiently. For example, hash tables use modulus arithmetics from number theory to store data in constant time. All right. So, and we do have the prime factorizations, all right, critical in cryptography and secure key generation. For example, the security of digital signature rely on the properties of prime numbers and their difficulty to factors. Okay, so all of these are the mathematical areas that directly apply to the computing pathway. Okay, so that's all for my sharings. Okay, I hope that you enjoy with this and you get some idea. Okay, how this max is actually related to computing pathway. So I will pass back to Dr. Nohayati. Thank you so much. Thanks for listening to this sharing.